Hello students, welcome back. We went through a nice problem, a very typical problem on interval estimations for population means when the sample standard deviation is used instead of population standard deviation. Well, one more example will not hurt, so let's go about the last example here. And this one came from actual data that took place in an experiment, a very, very famous experiment by Henry Cavendish on 1798. Stop the playback and read through. The density of the Earth is known to be about 5.517 grams per cubic centimeters nowadays. Henry Cavendish, an English chemist and physicist who lived from 1731 to 1810, was the first scientist to accurately measure the density of the Earth. He used the torsion balance experiment, which was originally designed to measure the strength of the gravity, as a matter of fact. Here is a data set based upon his experiment conducted on 1798, and here we go. So, unlike the previous example, which was kind of made up, this is real. Okay, all right. Find the 95% upper confidence bound from Cavendish experiment. Well, let's see. This is the data. So the mean is 5.44 something. Excuse me. I apparently clicked the wrong key. And the sample standard deviation is 0.2209 something, all right. So this experimental data gives you the mean of 5.4479, which is a bit less than the density of the Earth based upon today's measurement. And are they close enough? That's why I'm testing 95% upper confidence bound. Make it a little bit bigger. See if this is coming close. Let's find out. All right. Sample statistics are here. So there are 29 measurements. So so the degree of freedom is n-1. It's going to be 28. And then the mean 5.44793. Okay, this one. And sample standard deviation 0.22 something. And the standard error is s over square root of n. 0.041 something. This is something we are going to be using. Let's see. Now, these are just mathematical commands. Now, here's a picture. You can draw the normal picture like this, 5.448, all right. And then we want the upper confidence bound, 5.5% here, 95% there. Make sense? Okay. And then we are looking for this upper bound using the t-score formula. T is end minus center over SE. Oh, by the way, what was SE? Oh yeah, this. Oh, by the way, 5.448. Let's use a little bit more decimal digits. And increase the font a little bit further. And nothing is accurate in statistics, so let's use Wrigley quality sign here as soon as we put in numbers. And this has to be the t-score associated to 95%. Let's look up the t-table. 95% to the left and 5% to the right. And the degree of freedom is, in this case, 28. So here's a t-table. And 5%, so you have to look up this column. So upper tail is 5%, 5%. And then degree of freedom is 29. So what is it? We are looking at 2.040? No, 2.045. 2.045. Oh, excuse me, that's not right. 29 is a sample size. So degree of freedom is n minus 1, 28. So 2.048. 2.048. That's what we should look up. So 2.048. 2.048. From here, we can find out the U value. All right, that's what I did. Oh, wait a minute. Let's look up the t-table. I must have looked up a wrong column. 5% column is here. And for, yes, it's 1.701. I looked up incorrect column. So 5% here, this column, for degree of freedom of 28. So 1.701. That's what I want. 1.701. 1.701. So this one is wrong. I looked up incorrect column. Actually, that happens all the time, even during the exam. So be careful about those kind of things. I usually grade really leniently in that cases because misreading tables are so common. So if he's one off one way or the other, I don't take up a lot of points. But in any case, better to be correct than incorrect. All right, from here, solving for U, not too bad. Just algebraic method, and this is what we get. And what is it? Upper confidence bound is 5.518. So the one-sided unbounded confidence interval is 5.5178 to negative infinity. Of course, it's just theoretical, you see. And we go to negative infinity because nobody cares about left-hand side. And density of the Earth is always greater than 0, though. In any case, compare this with today's figure. Today's figure of 5.517 grams. It's within this confidence bound, isn't it? In this confidence interval. So do you appreciate the experiment done by 18th century scientist about the density of the Earth? It's amazingly accurate. All right, there goes one example about T-curve analysis and interval estimation for population means. And of course, I could have given you a confidence interval problem instead of confidence bound problem on Cavendish's example. There are other examples like these too. So whenever you have sample data, consider t-table.